wet weather here in California these past few weeks has been nothing short of astonishing, especially after the drought we've all been learning to live with. So we could be forgiven for feeling a little bewildered by what exactly has been going on with the weather lately. So now I'm going to take just a few minutes and talk about the nature of the storms that have slammed into California over the past few weeks. One intriguing term you may have heard recently is atmospheric river. It was an atmospheric river that brought the most rainfall I have ever seen in the Bay Area on New Year's Eve, December 31st of 2022. Just like a normal river, an atmospheric river is a narrow body of flowing water, but instead of being made up of liquid water moving on the surface of Earth, atmospheric rivers consist of water in gas form, water vapor flowing through the air overhead. This is not some weak metaphor. Atmospheric rivers transport just as much water, sometimes much more, than the Mississippi River, just in the form of water vapor rather than liquid. Atmospheric rivers are typically created when plumes of humid tropical air are carried out of the tropics by large vortices or swirls in the atmosphere. As the northern part of one of these plumes or swirls gets caught up in the fast eastward winds of the jet stream, it gets stretched out into a long and narrow band, often thousands of miles long. If we look at this animation of the amount of water vapor in the atmosphere back around New Year's Eve, you can see an atmospheric river that's over 3,000 miles long, and it really just hoses down the west coast of the United States. Atmospheric rivers are usually created by extratropical cyclones, which are rotating patterns of wind over 1,000 miles across. Maybe during one of these intense rain events, you heard the term bomb cyclone. Cyclones have low pressure at their center, and when that pressure drops quickly, meteorologists like to say that the pressure has bombed, by which they mean that the cyclone has intensified rapidly. This is what happened on January 4th of 2023. Satellite imagery from that date show this beautiful classic comma-shaped structure of the clouds in that cyclone. Upward motion in cyclones lifts humid air, cooling it as it moves to lower pressure, as it goes to higher levels of the atmosphere, and causes the water vapor to condense and fall out as rain or snow, sometimes very intense rain or snow. Why have we seen atmospheric rivers and bomb cyclones hit so close in time to each other this winter? Well, it is first important to remember that winter is the rainy season here in California, and we do need multiple atmospheric rivers and cyclones in that season to make up our average amount of yearly rainfall, recharging our reservoirs and building up our snowpack. That is not to say that this wham-bam sequence of atmospheric rivers and cyclones was not remarkable. But why these systems cluster in time is, unfortunately, very much an area of active research. A neat fact is that the atmosphere obeys mathematical laws of fluid motion, just like the water in your kitchen sink or the flow of blood through vessels in your heart, enabling us to simulate simplified atmospheric rivers and cyclones on supercomputers. Here is a simulation of the water vapor content of a hypothetical planet, very much like Earth, but without any continents. If we let the atmosphere spin up from an initial state of zero wind, you can see high water vapor start to form in clusters over the warm tropical ocean. And eventually the jet stream spins up and cyclones form and start to stretch the water vapor out into atmospheric rivers. We can take this sort of simulated world and subject it to various influences like increasing its carbon dioxide content or changing the temperatures of its ocean, and use that to develop our theory and understanding of how atmospheric rivers, bomb cyclones, and other storms vary year to year in the current climate and how they might change in the next century or two. This is work that is not only scientifically interesting, but as I've learned from living through drought and wildfire and now flood here in California, really important for knowing how to plan for the next century of life in this state.